Hey boys and girls, welcome back to Munro Live. I'm here with Aaron Wiegel from Wiegel Solutions Manufactured. And believe me, I'm sure this is going to be a great tour. Anyway, Aaron, can you give us a little background, a little something on you, and tell us a little bit about the company?
Sure. Thanks, Sandy. Aaron Wiegel, President and CEO of Wiegel, formerly known as Wiegel 2 Works, and we just recently dropped that acronym because of all the different capabilities that we now offer our customers. We're a third-generation owned business. My brother and sister and I are the third generation. My grandfather started it back in 1941 as a tool and die shop, and over the decades and generations we've evolved from a tool and die shop to a metal stamping facility to now just doing a lot of different manufacturing with the stamping emphasis. Today we do a lot of patented roll welding processes, assembly processes, and we're into molding now in some cases. So just a lot going on here because we want to make sure that we are providing everything that the customer is looking for as a one-stop shop place as we start to grow and add on additional capabilities and expand our footprint, not only in Chicago, but now heading into Mexico in 2024.
So, Aaron, thank you first off for letting us get going here. But also, I'm really looking forward to walking through your facility.
Thank you. I'm looking forward to showing you. I think we have a lot to show here, and certainly we have a lot to be proud of.
Great.
And my family's got a lot of legacy here that I'm happy to showcase.
Great. Excellent. Well, let's go and see.
Thank you.
Okay, Aaron, what the hell is this? What am I looking at?
Well, Sandy, what you're looking at is a machine you've probably never seen in your life before because there's only 4 that exist in this country, and you're looking at them.
Looking at all 4 of them? Really?
Yeah. This is a patented welding process that we co-developed with 2 other partners in the United States to be able to produce the products that we're making for our customers. Custom machines. And we're about to show you a little bit of what this thing does. But as an example here, we're marrying 2 different aluminum materials together to produce a welded component here. So here's the after, and this is the before. So you have an 80,000 stick aluminum bus bar, and that's welded onto a 5,000 stick aluminum foil. All precision made and located.
I recall hearing about our guys looking at this and not knowing exactly what they were looking at. So it does this weld right here?
Yes, sir.
Well, I have no idea what I'm looking at, so that doesn't happen very often. Yeah, this is kind of cool.
Yeah, so we'll show the process here, and then I'll show you how this is actually consumed.
Okay.
So there's 2 mating parts to this process. So on this side, we're introducing, and we don't want to break the light curtain. We're introducing the stamping that we have at another facility, which we saw earlier today, with the bus bar, into the machine, and then it goes through our welding process, and at the end it produces a welded component. So we'll walk around to the front. So from a front view, on the left side, on this table over here to the left, we've got custom fixtures that we put our bus bars into to have the precision location in order for the automation equipment to pick up these components, put them into the welding cavities, and then we bring in the second piece of material, which is the aluminum foil that we are stamping inside this piece of equipment. overlaying it on top of our stamped part, and then we go ahead with the welding process with the fixture locating everything. We have the material coming in, it's going through the stamping process, stamped, and then we got the parts produced. So in this example, we're introducing the bus bar from the right side with a FANUC robot. From the left side, we're stamping out the aluminum foil, overlaying on top of the bus bar. These welding fixtures that have a series of holes that use suction to hold down the aluminum. It's compressed through a roller and then sent through our patented welding process in order to weld the two materials together. It's got a revolving fixture system that rotates these things through, and on the back end of it is when you got your final part, the robot takes it out of the fixture and spits it out of the machine.
Amazing. That is amazing.
It was our first taste into welding into automation. It was just been a complete success. And since then, there's about 52 robots in this facility that we're utilizing. This particular machine, I believe, is 3. You can see the fixtures coming through, and it's going through each series of welding heads. All the welding heads are customized, and it's got specific Z depths based on the material thickness variation and all that, and it's all precisely measured in order to give us the perfect weld on each one of these particular parts. And you can see the back end here now. This is where the part has been welded complete, still in the fixture. The robot with this end of arm tooling is grabbing the part, removing it from the fixture. Once the fixture has been emptied out, it's cycled through and brought to the beginning of the process in order to recycle this process all the way through. And as I said earlier, all these machines are designed and built the same, but the fixturing and the part configuration are different. There's 4 different versions we produce here. So Sandy, we reached the final phase of this one product line where I was showing you the patented welding process. That's actually a part that we make that we actually consume in this assembly process, where we marry all the different components that we make in-house or outsource, put it together to get a final part, which is fully automated with just labor involved that's just in-feeding and exiting materials in and out of the machine. So it starts with these 3 Komatsu presses where we're in-feeding all of our welded components into this set of tooling that's fully automated. As you can see here, this particular cell, it's one of 3 that has a robot that brings the material inside the tool, and then there's a transfer arm system that carries the material throughout the 3 stations of the tool, and then there's another FANUC robot on the back end that takes it out of the tool, and then we put it into a general fixture that is used that's carousel throughout the entire process in order to get this thing fully assembled. So right now this is being in queue. Once this thing is cleared out in the die, it'll fire off. So as you can see, the parts are being moved from station 1 to 2, 2 to 3, 3 to 4, and then the robot will introduce a new piece here, and that process will continue as we start the automation process.
So this actually is not like the other units that we saw, which are progressive dies. This is a transfer die.
This is an example of a transfer die, yes.
Small, but definitely that's what we're looking at.
Yes. It's a loose piece that's being transferred from station to station with a transfer mechanism, yes. And what we're doing here is taking the welded foil and we're cutting and forming the welded foil into tabs used at the end user. And everything is inspected 100% with vision system.
So that's the raw stock here, right?
Yes. So this is the welded components. This is another fixture type, and you got the welded components, and that is put onto these conveyors and introduced into the machine, where the automation system will take it from there and move the component into the tooling and start the process of marrying everything together.
Cool.
So we can walk on the back end there in a minute. I mean, that's basically just 3 different machines taking the 4 different versions that we were welding together and marrying them into this fixture that flows through the entire automation process. This fixture is designed with pilots that engage all the pilot holes we have in all the different types of materials that we're introducing into the fixture. And that carousel is rotated throughout the entire process in order to marry everything together and assemble it and then pack it out automatically. We purchase these plastic frames from a local supplier. And the bus bars are actually glued onto this plastic using a special glue and hit with a ultraviolet light to cure it immediately.
So just out of curiosity, with whatever I've seen here so far, this does not look like something that you couldn't do yourself. So why do you send it out?
We did not have the capability of making and doing this mold at the time, but something that as we continue to go down the road of quoting these types of programs and these projects, we investigate these types of processes to see if we're going to bring in-house. And that's why we dropped the acronym Toolworks and just went with Wiegel, because throughout this journey, we've always been adding more and more additional capabilities. As an example, 2017, I had 0 robots, and today I have 52. I didn't have any welding capabilities. Now I have 4. Here's the other 2 stamping stations. Again, different bus bar configuration, same operation, being fed onto the main fixture system. Same process with the same vision system in play as well. And I'll also note too, Sandy, if you could see this, I know we talked about this technology earlier in the other stamping facility. If you noticed, if you look at the ram speed, it's fast and it slows down, and it's fast again. That's servo technology. And that's something you cannot do on a mechanical press.
Yeah, and mechanical press is just a big cam.
Right.
But that's why I asked for, and initially I didn't get it, but that's why I asked for it when they put me in charge of that stupid ass oil pan line, because I couldn't make it work. If I tried on a tri press, well, the guys.
If you're going to do draw work,
yeah, you
got to have a servo.
Absolutely.
You get draw work, you got to have a servo.
The oil pan was drawing down. I mean, it was worse than pots and pans.
So here is the station where now we have a set of bus bars all glued to the plastic frame, but we now have to make the connection from the bus bar so that they're all talking together, and that the energy that's being extracted from the bus bar flows out of this piece. So in this particular operation, we introduced the bus bars with the plastic frame. We're locating the XY on the plastic frame, and then we're applying a flex circuit board to that frame that is going to be used to be later on in the process connected to the bus bars, welded with a nickel ribbon, and to extract all the energy that's coming out of the bus bars.
Right.
So the robot to your right is locating the flexible circuit board, removes the backing to expose adhesive, use a vision system to check whether or not it's a positive or negative flex circuit board, locates it on the frame, applies it, and then similar to, like, for instance, on a cell phone, if you want to put a plastic protector on your screen and you got air bubbles, it's the same thing when you're applying this circuit board onto this frame. You have air bubbles on the adhesive, so all we're simply doing is rolling it out. So what we're doing here is we are applying a nickel ribbon material, and we're laser welding this material from the circuit board copper component to the aluminum bus bar, and that completes the connection between the bus bars and the circuit board that allows the energy to extract out of the circuit board into the plug and onto the final component. The rev level, the data manufacturer, the serial number, and then all is then encompassed into a QR code that's also laser marked on there, so that when the customer sees it and zaps the QR code, all that information is uploaded into their system. And once that is completed, it's then put into the plastic thermoform container, and that's packed out into a skid. And once the skid is full, the robot will kick it out, and all the operators need to do is put a cap on it, band it, and off it goes. Very little labor involved. Yeah, so this is empty tray. So once this is full, it'll come out.
Yeah.
We put a top on it, and that's the final stages where it's the operator's responsibility to get a full skid out and keep always an empty trays of a full skid ready to go in queue. So welcome to our high-speed department. This is where we have all of our high-speed brooders running all of the dies that we have designed and built for all of our customers. Typically, these machines are producing terminals and smaller thin gauge items at a high speed to produce a lot of the output per hour. So this is where these machines are focused on.
So what are the strokes per minute on something like this? I'm assuming that's aluminum over there.
That actually is a tin plated copper alloy. And these machines are capable of running up to around 1,500 strokes per minute. That number, that strokes per minute, is all really determined on the tooling, the die, and the performance, and what the progression is, and what the stroke's going to be. So all those parameters dictate how we produce these products. So it's really based on the tool design rather than the machine, the press itself.
So these are really, the material here looks really thin. What are we looking at here as far as thickness? Let's look at this one,
Sure.
seeing as it's closer.
Well, we run as thin as 3 thousandths thick, so it's basically foil. And typically around in this room here, we can get up to like 60, 70 thousandths thick. That's really kind of the max on that. Anything more than that, you're looking at more of a different press with a different tonnage, because you're going to be requiring more tonnage to not only cut through that material, but also forming it.
Yeah, right. So the big question is there anything we can see at the end of the line? Like, is there an example of what, what the product looks like when it comes out?
Absolutely. So this is an example of a press that you have. It's all standardized, where you have the coil being fed out, goes into a straightener, then into the production machine, and then goes through possibly a vision system if it requires that, and then a post-packaging process. So it's all in the same order of operation. So this would be the beginning. At the back end of it, this would be a terminal that's being wound up on a disposable reel at the customer, cardboard. So the end product would be being stamped out right there with all the samples at each one of the inspection benches. So in this particular case, with the high-speed terminal, it's being checked 100% through our cognitive camera system, all looped into our network that the operator can see at their station, but anybody in the plant that has access to the camera system and to the network also has that ability to see what the inspection is. 100% inspection on critical dimensions. We do CPK and all the dimensions that the customer really is calling out that's critical, we check 100% when we can. And in this case, it comes on a strip where you could pick up the location and it's the same every single time, rather than it being a loose piece. So it makes it more of an applicable situation to be able to program a automation system, a vision system onto this type of program. Here's an example of what we were talking about in the briefing, where we're making a heavy gauge terminal. This is, I would say, medium gauge for us. We have seen heavier ones, but this is for higher voltage type of current that is a high volume runner for us here at Wiegel.
And what is this terminal used for, or dare I ask?
So it goes into a wire harness application, and I know it's used for battery systems. Now, what specifically to go in the car, that's not stated, but I do believe that this is just a generic wire harness or a custom wire harness that multiple automotive OEMs just buy from the tier 1 suppliers.
So in this case, you'd be a tier 2.
In this case, I'm a tier 2, yes. They buy from the tier 1 on that one. the final one. And this is a copper-based alloy with silver plating. That's why we have special desiccant interleaf to preserve the silver so that it avoids the tarnishing.
So one of the things we haven't talked about is that these are progressive dies, which means that you start over here with just a ribbon, and as you move through, different things are happening. So maybe you could, give us a little brief on that.
Correct. So that's why we call it a progressive die. There's a number of different dies that have an acronym in front of it: transfer dies, progressive dies, compound dies. For us, we're predominantly progressive dies, and that's exactly what it means. Progressive meaning each station, it does a different application, but it's being moved from station to station with the carrier from the metal. So it's always attached to the original coil until you're at the very end, where you either cut it off or you sell it onto the metal, where the end user will then use its tooling or application in order to cut it off and make their final product. So,
and that's what we see here.
Exactly.
These are all connected.
Yes.
And sooner or later they'll be clipped off and
they'll be fed into their equipment to where the wire harness will be attached, and then it'll break off from our carrier strip. So, and in the beginning, you'll typically see a lot of cutting going on, and then you'll see forming, you'll see coining towards the back end of it, and that's when you get your final product.
Yeah, good. So there is some scrap. I'm assuming it shoots out the back, or it's going straight through the lower plastic.
All the scrap falls through the bottom, and it's accumulated at the bottom. That's one of the very critical parts of the operation in order to be cost effective. If you don't have proper scrap management in our business, you don't have a business. All that is accumulated, weighed up, sold back to either the original metal supplier or scrap dealers, depending on the type of alloy and any type of special plating that intermixes the alloys that require some post-processing before they can go back into the casting process at the mill. But all that is managed and weighed up and inventoried because it's a key part of our operations.
Excellent. Well, I can hear something even bigger thumping. Let's go and have a look at that.
We're graduating into the bigger boys here.
Yeah.
So as we move along, this is where we get into the heavier stamping equipment. So now we're looking at the Minster brand. The Wiegel family has always had the mantra of sticking to the brands that we grew up with, that we know, and that we train. So we have the Bruder brand, and now we're going to the Minster brand, which we feel is the best brand for the heavy stamping applications based on the robust design of the press, the cast space, and there's just a long history of the Minster brand built here in Minster, Ohio. This is a 160-ton Minster press. As you can see, the die is a lot bigger and longer. There's a lot more stations in this tool. So in this particular application, which is what we specialize in, typically you're going to buy a bigger press that required a tonnage. We buy these bigger presses really for the length, because we're doing a lot more in the die as far as stations and to be able to cut and form these particular parts. So even though this is 160 tons, my guess is this press is probably generating maximum 50, 60 tons in order to do this part right here. But I can't do this in a high-speed Bruder because I don't have the length required to put this tool in and do all the different things that this die is doing station by station in order to get to the final product.
Can I bugger things up and grab one of those so we can talk
Absolutely.
about it?
Yeah.
Hey, Eric. I'm going to talk about this. So anyway, what we're looking at is one of the pieces that's coming out of this Minster here, the 160-ton thing. So we're looking at I don't know, some sort of a connector or contactor, and this is like amazingly thin, and this is not the kind of stamping I did when I was a tool maker. Can you describe a little bit about what's going on here with this? Because if you look at, I don't even know how you nest this. So
So this particular part, this is a very interesting one actually. There's a lot going on between these two terminals. You got a, I believe this is a 16,000 gauge material, but the challenge here, and that's one of the reasons why we won this job, is because the actual connector had to be double the size. So we have a holdover feature on this that makes it 32,000 at the connector point, but the terminal is actually 16,000, and all those holes are precision pilot holes that the end user, which in this case is the insert molder, uses to place these parts into their mold, and using those pilots into those holes to properly put it into the right location. Then it shoots the plastic and the resin through it in order to get the final product.
So the little holes are actually the things that draw my attention to this thing. Okay, I know how to bend that and this and whatnot, but hitting all these holes, usually I do that first, and then I do the bending of this contoured shape. I can't even imagine. I can't even imagine how I could possibly, because each one of these things looks dead nuts in the right place.
That's because it is.
Yeah.
Every station, there's some type of piloting to put all that into location to make sure that once the operation, the press comes down and you make impact onto the part, that prior to impact, everything's in location by the pilot, engaging it into those holes. The stripper comes down to clamp it, and then all the other tooling follows behind it and does exactly what it needs to do, and to ensure that everything is in the right location so we can hold those dimensions, especially the cut dimensions on that, because if you're familiar with the molding process, the last thing you want to do is have any flash. So when you clamp down on the mold and there's some metal sticking out, that's got to be plus or minus 1,000. And if you have anything outside of that, you'll have flash in the mold, and you're going to have some issues at the molding process, which will never work for the customer.
So that's the other thing I was going to ask next is I don't feel any flashing at all, and that also means these dies are dead nut sharp as well. So
absolutely.
Very cool.
So this edition here was put in 2011. This is where we have 30 tons all the way through 160 tons. This edition is where we have the even larger equipment. This edition was put in 1997. And we have presses here, all Minsters, ranging from 100 tons up to 450 tons. And one Komatsu press here as well, which is a servo press.
Yeah. I will tell you, Komatsu, I do like Minster. Komatsu is one of my favorite presses.
Over here, this is our 350-ton Minster. And what we're stamping out here is a thin gauge, well, I would say medium gauge, copper-based material with tin plating once more. And this is a thinner gauge bus bar.
Let's go over here and have a look. So again, over here we've got the decoiler, the straightener, and then the feed.
Yeah, this is a more higher end line. You definitely got the decoiler, but the straightener is a higher value piece of equipment here. This particular piece of equipment has 19 rollers that is flattening out the material rather than your standard 5 rollers that may be about 4.5 to 5 inches in diameter. This is about 1.25 inches up to 1 3/4 inch diameters with backup rollers behind it to help with the deflection. And based on the yield strength and the modulus elasticity and the thickness of the material, that's how you dial in your exit, or your entry and your exit of the material to get the most flat material you possibly can as you enter into the tooling. And then not only does it have to be flat, it also gets rid of all the internal stresses, because as you do a lot of intricate forming,
you must be roller burnishing as well. With 19 rollers or whatever, you must be like burnishing the surface.
It's applying a lot of pressure, and yes, you know, definitely the material surface finish is different from entry to exit, but the overall thickness and the performance of the plating and the material will not be affected.
But the thickness will be uber consistent. If you're going through that many rollers in a straightener, I've never heard of that, never. And especially something in that small. That to me is like amazing. 3, 4, 5. I mean, I think I might have seen something that had 7. but I've never heard anything like that.
Well, that's typically where you see it with thick steel parts.
Yeah.
And you know, if you're doing thick steel parts and you want to try to bend 90 degrees, the spring back on that is not coming to play. But when you're dealing with thin materials and the tension inside, if I'm trying to hold a 90-degree bend, every little bit helps, and including getting rid of all the tension in the material. And that's why you have to go with these precision straighteners. So here you have a thick bus bar with 2 pilot holes that you would typically put into an electric vehicle, a battery discharge unit, with the holes locating it and being fastened on.
So this one again is quite a bit of scrap in cranking this out. Or
So
not
that's-
scrap.
that's-
You shouldn't call it, it's offall really.
Yes.
Because it's usable someplace.
That is the challenge in bus bar manufacturing is, you know, when you look at this sophisticated line, although there's a lot going on here, the biggest cost driver is the material. It represents anywhere between 50 up to maybe in some cases 80% of the cost of manufacturing. And scrap management, what I said earlier in the day, and I'm saying again now, especially with thick bus bar copper material, that's expensive material to run, trying to reduce the amount of scrap you're generating is the key to success in this bus bar technology. That's why this is one of many options that we have here that you can make bus bar technology or bus bar parts. Because you have the geometry where it's not just a straight line, it limits our ability to do it in any other type of operation. It has to be done in a tool. And because it has to be done in a progressive die, you're going to have more scrap than the way this is particularly designed.
Okay, so this has got a flash in some of the different areas. Is this tumbled or anything, or is it just not? You don't care, or you don't need it?
It depends on the customer specification, what the application is used for. On some cases, we can get it tumbled. In most cases, we'll have die killed in the tooling to get rid of the burrs. Sometimes it gets insert molded where all that's buried, so it's irrelevant. But in this particular case, well, this will be a stamp and ship part, and it'll be sent off.
Where is that done? On this press?
So we have a post operation on this particular part where we're putting PEM insertions into these parts. Some of that can be done off press, and some of it can be done in die. So we have both applications. Really, if you're going to do it in die, it really depends on the part design, which may or may not allow us to be doing it in die.
But feeding, I did a lot of this kind of stuff when Tim first came out and said, "Hey, you can do this," blah blah. We actually tried, and the ability to feed it in, oh man, that was not a nightmare, but as close to a nightmare as you can get. So what do we got over here?
So this is the sister press that we have versus the 350. One of the strategic things we do as far as a company and from a risk mitigation standpoint, anytime we make an investment in a significant piece of equipment, if possible, which in a lot of cases it is for us, we always buy 2 machines because I want to make sure that I have the ability that if one machine were to go down, that my first line of defense is going to my secondary machine. Otherwise, we have a contract with a number of other stampers in the Chicagoland area where I can be using other pieces of equipment around the Chicagoland area to make sure that we don't ever shut down our customers. This particular press has got a die in there that's making aluminum bus bars for a current collector assembly for a major electric automotive manufacturer. There's 4 different versions of these bus bars that we produce that we end up consuming in a different facility that we have that assembles the part completely and makes the current collector assembly that draws out all the energy out of the battery cells and flows it into the vehicle. So this particular assembly that we'll see later on in the tour will be mounted onto the battery pack system of the OEM of the electric car manufacturer. Key to manufacturing is to make sure that you're consistent and you eliminate a lot of the variables. And so, you know, we already have enough variables that we deal with a day-to-day with our tooling. The last thing I want to do is introduce any type of variables with equipment that we may be limited options. So we buy the most advanced pieces of equipment to make sure that we eliminate those variables. So in this particular case, once again, yes, this is a a straightener that has, I believe, 13 rollers with backup rollers. They're 1 3/4 in diameter. And all of the exit and entry settings are all calculated based on the type of material you're using, the thickness of the material, the yield strength, and the modulus elasticity parameters. They're all pumped into a database that we have created to give you the entry and exit parameters, so everything is set consistent. And if there is any type of tweaking of that, we're always looking at the certificate of conformance data sheets from the supplier for the material to make sure that maybe the yield strength might be a little bit on the high end or a low end of what it normally would be, and we will make those adjustments to make sure we have the most flattest, stress-free material entering into our tooling.
That's a perfect lead-in. Hey, Eric, can you come here for a second? I want you to get as high as you can and show the curvature. You can see little bumps on the raw material after it comes out of the uncoiler.
So that actually is not from the coil set. That's actually from
here.
The straightener. That's the 3-piece arm that's stretched out.
Yeah.
So when you get to the inner coil, you'll start seeing that. But
that's the reason for this, and that's
correct.
What I want to.
That's one of many. Yes.
Yeah. So now that you've seen that, slide over here and look at the end product, and you'll see it's dead flat.
Yeah, all this is incoming raw material. These are all, in this particular material, is all aluminum. So we are a very big consumer of aluminum materials, and really it's for multiple applications. But we're finding now that the bus bar technology, a lot of customers now are using aluminum rather than copper for a number of reasons. But the biggest reason is because they're trying to lighten up the car because it's already a very heavy car with electrical vehicles, and obviously the electrical conductivity. So this is why aluminum is really starting to come into play now as far as the bus bar technology.
Wow.
So this is the Wiegel Quality Lab. It's a little chilly in here, but it's by design.
Yeah.
It's 68 degrees year-round, and so that way we do all of our quality inspections in a consistent temperature. And as you can see, there's a lot of cool toys in here, from CMMs to vision systems and to
an optical comparator. I haven't seen one of those in a long time.
Well, these are starting to become obsolete, even though we do use this. But this particular piece of equipment, both of them right here, the OGPs, really have taken away a lot of the optical comparator checks that we were doing, back in the old days. So this is all automated, and again, it goes back to eliminate variables. You can get variability from part to part, person to person. Here, it's one of those you set and forget it, and it just, the output of this particular piece of equipment to get you consistent dimensions so much quicker is worth its investment in gold. So, and not only that, all that data is uploaded into a spreadsheet right away rather than typing it in. Yeah. It's available to the customers when needed. We keep all those records, so it's just the next generation of how we do things when it comes to in-process inspection.
Way cool. Yeah.
So you have the OGPs, you have Keyence vision systems. We've got surface prolometers, Rockwell testers, height gauges, obviously the micrometers and the calipers. Yeah. Millipore testing for cleanliness. Virtually every single quality check that is required in our facilities is in this room, and they're doing first piece, last piece, and then in-process inspection periodically while the operator is doing more frequent checks, but that are noted on our PPAP plans.
Cool.
So welcome to our wire EDM department at Wiegel. So this is really part of the process of how we make all of our progressive dies within our facility. Everything is all designed and built at Wiegel. And as far as the precision and where the most important part of the process is when it comes to making our tools, starts right here. This is a climate-controlled room, 68 degrees once again year-round. All these are MITS brand wire EDM machines. Typically, we like to flip our machines every 5 to 7 years because the technology on these machines change so quickly and just they so much improve, whether it's just the speed of the machine itself or even the wire consumption. So what we're doing here is we're wire EDMing all of our die blocks, punch plates, strippers, and then all the guts of the tool when it comes to the punches, die inserts, wafers, all really are done here and brought to the tool shop to do all the final grinding and assembly. So this is a very, very key part of our operations.
So wire EDM basically it's called an electric discharge machine.
Correct.
And it has a wire that is pre-programmed into the unit, allowing you to burn, if you like.
Exactly.
And now we can see it. So why don't you
So
dive in?
here's an example where we're taking 260 brass wire that's typically anywhere between 8 to 10 thousandths in diameter, and we're programming it because it's a CNC controller. We're programming it where we're hovering the device over pre-drilled holes in these blocks of steel, and the wire is fed through that hole, and then the female captures that, and then we electrify the wire, and we're essentially burning the steel, and then the CNC program itself with the G code goes around the XY directions that we have it pre-programmed. This does have a Z component to it, but typically this is more of an XY type of a process, and this is a process that's extremely accurate. You can hold millions on this, and this is where all of our accuracy comes from. So this is Wayne Petrowski. Wayne Petrowski has been with Wiegel for a little over 45 years. Wayne's in charge of our wire EM department and has been in charge of this department and worked in this department for nearly 35, 40 years?
38 years now.
38 years.
Something like that.
So he has seen the entire evolution of wire EM technology going back to where the machines were,
Astronomical.
Yes.
It's completely changed. I remember as a child coming into this room where all the programming was fed by brown tape with dots. That goes back to...
They came out with little cards initially.
Yeah, well, there you go. So here you can see as an example, if you ever want to see from a side view of how this is actually burning. So it's not cutting here. This is an operation where it's actually burning the material. That's a side example of how that works.
Yeah, right now I'm just skimming that, taking about 3/10 of an inch, 3/10 of material off of that. And the next pass will go even like 2. I can hold plus or minus 1/10 all day long. And this is a piece that I'm cutting a 3-degree angle and a radius at the same time. So that's why it looks straight and then it's on an angle. It's because it's actually kicked back and running on a 3-degree, like a taper.
Yeah, yeah.
So it's just, I put it on 3 degrees. I could go further. The machines are capable of up to 45, but that takes special guides and special programming and everything. So we typically go up to 10 degrees on some of our work for 4-axis. Now we're also able to program X, Y, U, and V. So the top can go one direction and the bottom can go another.
Yeah.
So you can have 2 different shapes in one.
Wow, that's cool. I did not know that.
Yes.
But the angle is a good idea, especially if you decide to get into plastic injection molding.
Yes,
you can burn in your draft angles.
Right.
And that's exactly what we did. That was why we bought them, is because the company that I was working for when I was a kid, they had, I was a tool maker and I worked on stamping dies, but they didn't see that much of a difference between stamping and plastic injection molding. I got molds or dies and I've got machines that go with them. So those guys, they'd do anything. And with this, if we could put an angle on it, wow, that was an easy easy pick.
We do draft tapers all the time for slugs to get them out of the die openings. And we've come up with ways to cut them inside without even taking on a punch. We can put them on a punch now even.
Really?
It's crazy, yeah.
Wow.
So the punch can have clearance on the backside or reverse taper for strippers. So it comes out and there's not as much drag on it. So you only have land for that. So it's just the reverse of a die opening.
Right, yeah.
So it's we can get pretty elaborate.
And essentially from a die making point of view in the process, these pieces of equipment have eliminated a lot of jobs when it comes to just grinding pieces together and putting it together like a jigsaw puzzle. That's how they were made back in, predating the wire EDM machine. So this has completely changed the industry when it comes to die building. So the next machine we're going to show you is actually pretty rare in a tool room. They're pretty popular in Germany and in Japan, and that's one of the things we noticed with the premier die shops, that this was a key piece of equipment that, although we don't use it quite often, what it does for what we can make out of it is gives us significant uptime on our progressive dies. And what this does is it's just grinding a profile that the punch itself could be so small that there's no way of fastening it unless you're grinding a notch into the tool and then just clamping it down. But when you do that and you apply all of the statics and dynamics theories, like you apply all that tonnage on a punch and you are hitting a notch that doesn't have a backing to it, it tends to crack and break, and that's why you have a die that goes down. So as an example, and this is a profile optical grinder that able to grind that profile away, and it's all CNC controlled. And to date, I'm not even aware of this ever even breaking.
Okay.
Here's another example.
All right. Well, I have never seen one of these.
Yeah, I'm not surprised.
Well, this is brilliant, and I will tell you, if this is a punch,
that's a punch.
Yeah, I give you about 30 seconds, and then, but this with the backup, as you move into anything that could create a stress riser, you put that radius
Large
on
radius,
there.
Yes.
And then what happens is the amount of force up here doesn't turn into a problem like it would here. So this is going to want to bend and break. And I don't even see a whistle notch on that. But this one, what's going to happen here is it's going to be fully clamped. I just have to drop it in because for the most part, once it's sitting inside the tooling block, it ain't going to move. But with this, my chances of success are much higher than that. And like I say, have never seen that machine before.
Right,
and
it's its own climate-controlled room as well, and it's actually sitting on its own foundation. That the thickness of our normal concrete floors are 6 inches. This is sitting on I believe it's 3 feet thick, deep block for just getting rid of any vibration from the presses. It's even got a 1-inch cushion for that block. So we try, again, it's eliminating variables. So whether the presses are running or not running, I don't want to be introducing variables when we're grinding a tenth here and there.
Yeah.
So again, once again, just with the Wiegel philosophy and loyalty to our vendors and our brands, we've selected the Akuma. We've done a number of tests with a number of different brands, with Haas and Mazak and Makino and all the rest. We found Akuma to be the best brand for us from a performance standpoint. Certainly one of the key things when we look at different brands is all about service and quick response time. Considering Akuma has local services here, it's another reason why we selected these two brands. We got 2 different types of style of machines here. Again, this is something that my dad, as he traveled the world, he was talking to me and preaching to me about not only the optical grinder, but also CNC machining centers. What we see and being filmed right now is a standard vertical machining center, which you're going to see in 99.9% of shops out there. However, when my dad took a plant tour in Japan, that's all my dad saw was horizontal machining centers, and he kept on asking why. Well, it's pretty simple. You're only making money when you're cutting chips. And on a vertical machining center, when you're done with that workpiece, you're not cutting chips. On a horizontal machining center, when you're done cutting that workpiece, you're flipping the tombstones over and you're cutting chips immediately. So the setup time is done offline versus online here. Now, yes, you can get staging tables and you can do all that, but it's all done manually on a vertical. But with a horizontal machining center, the setup time is drastically reduced.
Aaron, I've had a hell of a good time. I got to tell you, and I don't get stumped too many times. You got me twice. So I'm really impressed with all the stuff you've got going on here. I've just had an amazing afternoon. This has been really, really wonderful. So thank you very much for allowing us to come here and basically videotape all this stuff. Thanks for educating me on a couple of new techniques I've never seen before. And just in general, this has been brilliant. Thank you so much.
Well, thank you, Sandy. I appreciate you coming on. I appreciate you coming and seeing what we got going on here. I mean, our family and our staff are really proud of what we've accomplished, and to be able to showcase that is great. So And especially on your show, it's been got a lot of notoriety, and we feel proud and that we can even be here. So if you want to find more information about Wiegel, it's www.wiegel.com. And again, thank you for everything from my family, to yours. Appreciate
Thank you so much. Thank you.
Thank you.
And ladies and gentlemen, boys and girls, thanks for watching. Stay tuned. There'll be more coming up in the near future. Bye.